Hey guys, it's Steven from Legit Tech Tutorials and the Green Engineers, and welcome back to Waterjet Cutter. This is episode, I believe, 5. Let's see here. I think this is episode... Yes. Oh no, 6. Episode 6. So, I have not yet contacted Tronxy. I was super tired yesterday and work was coming up, so I ended up just, calling it a night there, and then I was going to talk to him in the morning and realize that they're a day ahead, so that it actually is Monday over there today, even before 12 o'clock. It's already, it's almost, sorry, not Monday, Saturday. It's actually almost, let's see. It is Saturday 2:30 right now. So I guess it's on its way to Sunday. By the time I wake up, it'll be Sunday over there for them. Actually, 8 hours, 7 hours. It's gonna be 9:30 something. So, anyways, yeah. So I haven't talked to those guys yet, but I do like this idea of using that printer. So we're gonna continue looking into that further and continue to develop that. So. Again, let's double check. What did I do with the tape measure? Let's double check all these dimensions here so we could proceed forward and or should we just assume that we're going to change all of the extrusion? I mean, really, this is fine for right now. I'm pretty sure I could get that to be within its travel limits, which I think is 19. The question is really, can I, basically fit everything in 17 inches. So that's another 7 inches shorter. That's quite a bit. 7 inches and then this guy will keep going. We'll probably go all the way up to the end, minus the size of this piece. And, oh, this is forward, so technically you're going to lose some there also. Maybe initially, and then we'll have to buy more extrusion, but we can model it as a mock-up right now. And then we could use this guy to do a initial test, because this will save us a lot of money on extrusion, controller, all that kind of jazz. Because what we could do is we could put that plate in the left corner, but what we have to do is we have to modify this sensor or get rid of the sensor because it has this Z sensor. So I really hope that we could talk to these guys and buy something without the bed and without the controller and the touchscreen and the Z-axis motors and all that jazz. But even if we don't, we'll be saving a lot of time and experimentation and all that stuff. Because really, the machine that we're going to design is pretty much going to be almost identical to this machine here. Anyways, so, because it has the same extrusion, I like the build. The build was basically going to be exactly the same. Obviously, minus all these other parts, and definitely not as tall as it is. I mean, it could be this tall because, again, with the water jet, if it's, let's say, it misses the plate altogether, I don't want it to be able to press all the way down through the water and blow through the bottom of either plastic or a piece of steel or whatever. Highly doubt it. But anyways, put that out there. So, okay, so let's go ahead and change the design here. And let's change the uprights to the 20 by 20. This is exactly 19 1/4 inside from here to here. plus, and then that's the long piece. The front side's the long piece. But we could have it. Oh, have them alternating. That's kind of weird. Let's not do that. Alright, so. Long side. And I don't need to take inside measurements. I just need to make this right. So this is the long side, which in this case it says Y. It's actually the X side now. I mean, it's pretty much 21 inches. And then this side. I'm going to say 18 inches. I mean, this is basically going to be very similar to the Omax, but a lot of this stuff could be got rid of. And I think we could shorten up the carriage as far as the width of the carriage, because the carriage is pretty big for what it needs to be. It's pretty wide, because again, well, it's about how we need it to be. I think it'll be okay. Anyways. So let's go ahead and redo general layout. Okay, so okay, and then let's do Z side, and then this is 40 by 20. Like so. And also there is another there is a netter set on the bottom, but this guy is let's say about, again, 21 inches. Because really, what would be nice is if we could buy all this stuff. We could just buy all these pulleys and how they're set up and how they have different levels on them. Everything's really good. It's got all the eccentric nuts. It's got all that stuff on it. Right? I mean, sure, designing it in here would be nice, but, you know, knowing that it works first also would be nice. So we'll see what's going on here. So that's good. Okay, go ahead and do that. Okay, general layout, update. Okay, so basically, and then we have a couple more on the bottom. So how this is going to go, see how there's this end here? That's because basically it needs to be rotated like so. This is actually the orientation. Oops. There we go. Like so. And where'd the other one go? Oh. Good, good, not good. And there you go. Okay. This is actually this is the long way. And then up. This is 20 mil, negative 20 millimeters. Or that. Strange. That one's pretty freaking flush. Really, really close. Not perfect, but close. Perfect. Alright. Then basically it does the exact same thing on the bottom. To keep everything square, all the legs square. Pick a corner. Just like that. Another long one. What? Oh. Okay, now I'm disoriented. Okay. Mirror short side. I really should be paying more attention to how this. How this thing goes together, but I'm just kind of fixing it after the thought. Okay, so everything looks good now. So how we're actually looking at it is this is actually how the front looks. Yep, everything looks good. Okay. Says 20 pounds. It's not 20 pounds. Ooh, so 20 pounds versus 600 pounds? That might be questionable. Okay, so now, if I could force this over. So it's just about 21 inches from the nozzle to the floor. So let's take a look at it. All right, so oops. Okay. So that's the interior volume. Now, okay. Number one, what type of losses are we looking at? So here, let's look at some. It's probably going to be steel, just because it's easier to weld. I'm curious. Not TIG, but MIG. I'm crap at TIG. Sorry about that. Looks like you can go really thin. You just got to use thinner sheet. You just got to use thinner wire, which I do agree. I do agree with that. So let's see. Sheet metal gauge. I think a pretty popular gauge is standard steel, galvanized steel. Galvanized steel might also work, but it's got oil and stuff in it, so probably shouldn't do that if I'm going to recirculate. Should probably just put paint on it. Or, what is it? Powder coat. That'll also help keep all the seals nice and tight and all that stuff. Alright, so standard steel. Gauge, say like 16 gauge, 0.060. So let's say like 20 or less. Because here, and then like the nozzle's an inch. So say like let's say like 1.5 feet, so like 18 inches. Why is it going this way? I think this is just standard A36. Okay, so now here is the question. Now if I okay. So now if I do this, oh, there's no bottom. Alright, so now basically what I'm going to do is go in here. Actually, let's just do distance. And then let's say if this was 2.5 feet, which is 18 inches. Let's say this is 1 inch below, so 17 inches. This is new body. Water. Okay. So that's the idea there. Body 3, properties, water, mass, 3386 divided by 16 equals 211 pounds. I'm pretty sure we're over time. 200, is that what I said? 211 pounds. So let's keep that open on my other page here. 3386 divided by 16. No, but basically that's bearing pressure, which it will do it. It'll do bearing pressure. So let's. But what we'll do is we'll hide that body. Actually, we'll delete it. Actually, I think we could do that in post processing here to go in. Oop. Sheet metal. Ooh, not sheet metal. Simulation. Static stress. Yeah. Okay. So, but first we're going to go into DOF view. DOF. Should have actually had that going in, but whatever. Fixed, and then automatic constraints. Everything's fixed. And then we're going to do some structural loads. Obviously the floor is going to hold it together in the floor, but the walls are going to try to buckle. Right? And so these are pound force 211. What I'm going to do, let's go back to the model. Okay, so there's a slight interference there. Anyways, locally. Hmm. Well, I will continue doing this. It looks like, oh. Yeah. Okay. There we go. So now we're seeing something. So there you go. Perfect. So yeah, so have something go across the top here, and have something go across the bottom here to keep this down. So another two of these guys. They do not have it here, so I'd have to buy those two pieces and have them go across and stiffen this up, probably with the 2020, probably with the 2040. And stiffen this up, and then it should run pretty well. So that's cool. Very, very cool. So safety factor, obviously here, minimum of 5, shows a lot of stress there. A lot of stress up in the corners, up in the seam, right, where it's being held together. All right. So this has been Steven from Legit Tech Tutorials and the Green Engineers. Thank you guys for watching. If you like this video, please subscribe for more videos like it, and I'll see you guys in my next video. Hopefully I get the my Zombie Alamo back running this weekend and get rolling on that. So thank you guys for watching, and if you like these videos, please continue to watch and subscribe, and I'll see you guys in the next one. Take it easy. Peace.